Hello, our fellow mathematicians.
Have you guys wondered how can we find approximate area under curve like this?
So in this video, we will learn about the area under the curve and the area between curves.
Here are the learning competences that are expected in all of you to learn by the end of this video. 1. Approximate the area of a region under a curve using Riemann sums in left, right, and midpoint. 2. Define a definite integral as the limit of the Riemann sums. 3. Compute the area of a plane region using a definite integral, and lastly, solve problems involving areas of plane regions.
Before we proceed to finding the approximate area under a curve, let us first learn the basics.
So first, what is a curve? A curve is an abstract term used to describe the path of a continuously moving point that bends or changes direction at least once. A curve is usually made up of many small line segments linked end to end, and such path is usually generated by an equation.
There are many types of curves such as the upward curve, downward curve, open curve, closed curve, simple curve, and non-simple curve. But in this video, we will only focus on the most common types of curves that we usually see in calculus.
Whenever we encounter this kind of curve on a plane, we begin to wonder, how are we supposed to identify the approximate measurement of a curve? There is actually a way to find the area of a region under a curve by using the Riemann sums. Riemann sum is a certain kind of approximation of an integral by a finite sum. The area of a region can be approximated using a Riemann sums, which is created by summing the areas of various simplified slices of the region. The Riemann sums uses the fact that the area of a rectangle is the product of the width and the height.
So, in this lesson, we will be discussing about how to find the approximate area under and area between the curves, where we will illustrate the left Riemann sum, right Riemann sum, and the midpoint Riemann sum. Let's refer to this example. With a given f of x of 5x cubed, using 5 points to compute from left endpoints.
First, we draw a curve with 5 points, 2, 4, 6, 8, and 10. In this curve, since we're using left endpoints, we're going to plot the first rectangle from 0 to 2, starting from 0, there is no height. Next is 2 to 4, 4 to 6, 6 to 8, until 8 to 10. We can observe that it is less than the actual area under the curve. Using the left endpoints, we get an under approximation or a lower sum. In the left endpoints, the rectangle always starts with 0. It is usually under approximation or has a lower sum.
So to calculate the area of each rectangle, we are going to use the formula area under the curve is equal to the width of each rectangle, or the delta x, times the height of y values or the function values at some particular sample point using sigma notation, or sum starting from 1 to n, where n is equal to 2. Basically, we need to find the area of each rectangle.
To get the width of delta x of each rectangles, we can use this formula, where b represents the last point, which is 10, and a that represents the first point, which is 0, and n is the number of rectangles, which is 5. So, delta x is equal to 10 minus 0, which results to 10 divided by 5. That gives us the width of each rectangles, which are 2 units long.
Now that the width is identified, we still need to find the height of each rectangles. In order to do this, we just need to substitute x from the f of x with the given points 0, 2, 4, 6, and 8. So, y is equal 5x cubed would be 5 times 0 raised to 3, which is going to be 0, 5 times 2 raised to 3, 2 raised to 3 is equal to 8, multiplied by 5 is equal to 40. 5 times 4 raised to 3, 4 raised to 3 is equal to 64, times 5 is equal to 320. 5 times 6 raised to 3. 6 raised to 3 is equal to 216 multiplied by 5, which results to 1080. And lastly, 5 times 8 raised to 3. 8 raised to 3 is equal to 512 times 5 is equal to 2560.
Now that we have the height and the width, we can now solve for the area using this formula. So, 2 multiplied to 0 would be 0. 2 times 40 is equal to 80. 2 times 320 is equal to 640. 2 times 1080 is equal to 2160. And lastly, 2 times 2560 is equal to 5120. To get the total area using the left endpoints, add all the answers to get the area. 80 plus 640 plus 2160 plus 5120 is equal to 8000.
Just to check and share, we can also use this formula. Area using the left endpoints is equal to delta x times f of x sub 1 plus f of x sub 2 plus f of x sub 3 plus f of x sub 4 plus f of x sub 5. So delta x is equal to 2, and we are going to substitute the x values with 5 times 0 raised to 3 plus 5 times 2 raised to 3 plus 5 times 4 raised to 3 plus 5 times 6 raised to 3 plus 5 times 8 raised to 3. So now we are going to apply the operations, and 5 times 0 raised to 3 is equal to 0. 2 raised to 3 is equal to 8 times 5 is equal to 40. 4 raised to 3 times 5 is equal to 320. 6 raised to 3 is equal to 64 times 5 is equal to 1080. And 8 raised to 3 times 5 is equal to 2560. We are going to add all the f values, which is 40 plus 320 plus 1080 plus 2560, which is going to be 4000. And we're going to multiply it to 2, which is going to be 8000. As we can see, either the way of solving, it will lead to the same answer, which is 8000.
But here, we can see that there are spaces above the rectangle, meaning the real answer is above or greater than 8000. If you want to get the actual answer of the area of the rectangles, we can use definite integration with the formula of the area under a curve from a to b for f of x. So, our solution will be area is equal to the area under a curve from 0 to 10 for f of x, where f of x is 5x cubed dx. In integration, first, we are going to get the antiderivative of x cubed by adding 1 to its exponent. So, 5x raised to 3 plus 1 over 3 plus 1, it will be 5x raised to 4 over 4 with a lower limit of 0 and upper limit of 10. 5 multiplied to 0 raised to 4 over 4 is simply 0, minus 5 times 10 raised to 4, 50,000 divided by 4 would be 12,500.
Definite integrals are used to calculate the area between a curve and the x-axis on a specific interval, which means that if you want to get the exact or actual answer, using the definite integral is the best choice. The difference between the left and right endpoints is when we plot the rectangle. We will start on the last point, which is 10 to 8, 8 to 6, 6 to 4, and 2 to 0. The answer that we get using the right endpoints is going to exceed the actual area under the curve, resulting it to be over approximation or an upper sum. Right endpoints usually starts from the highest value of the given and ends with a zero. Right endpoints usually result to over approximation or upper sum.
Now, we can calculate to get the width of the rectangles using delta x is equal to b minus a divided by n. 10 minus 0 divided by 5 would be 10 over 5 is equal to 2.
After getting the delta x, we can now solve for the height. 0 is not included since we're starting from the right endpoints. So y is equal to 5x cubed would be 5 times 2 raised to 3. 2 raised to 3 is equal to 8 times 5 is equal to 40. 5 times 4 raised to 3. 4 raised to 3 is equal to 64. Multiplied by 5 is equal to 320. 5 times 6 raised to 3. So 6 raised to 3 would be 216. Multiplied by 5 is 1080. 5 times 8 raised to 3. 8 raised to 3 is 512 times 5 is 2560. 5 times 10 raised to 3. 10 raised to 3 is equal to 1000. 1000 times 5 is equal to 5000.
We can now solve for the area of rectangles from right endpoints. To get the area of rectangles from right endpoints, we will multiply the delta x, which is 2, to fx sub 1 plus fx sub 2 plus fx sub 3 plus fx sub 4 plus fx sub 5. 2 will be multiplied to the product of 5 times 2 raised to 3 plus 5 times 4 raised to 3 plus 5 times 6 raised to 3 plus 5 times 8 raised to 3 plus 5 times 10 raised to 3. 2 raised to 3 is 8, 4 raised to 3 is 64, 6 raised to 3 is 216, 8 raised to 3 is 512, and 10 raised to 3 is 1000. 5 times 8 is 40, 5 times 64 is 320, 5 times 216 is 1080, 5 times 512 is 2560, and 5 times 1000 is 5000. 40 plus 320 plus 1080 plus 2560 plus 5000 is 9000 multiplied by 2, and the answer would be 18,000.
The left endpoint, which is 8000, is much less than the actual endpoints, and the right endpoint with 18,000 is much higher than the actual answer. But if we average both of the left and right endpoints, we can get a good approximation for the area under the curve. To get the average, we are going to use the formula area of left endpoints plus area of right endpoints divided by 2. So we are going to substitute it with 8,000 plus 18,000, which is going to be 26,000, divided by 2 is 13,000.
In midpoint, the point lies between or in the middle of two x values. We're going to draw the rectangle where the line intersects that point, meaning the points we're going to use are 1, 3, 5, 7, and 9.
We can use this formula to get the area of midpoint. So area is equal to delta x, which is 2, times f of x sub 1 plus f of x sub 2 plus f of x sub 3 plus f of x sub 4 plus f of x sub 5. So we are going to substitute each f of x with the value on the midpoint, which is the 1, 3, 5, 7, and 9. So it will be 5 times 1 raised to 3 plus 5 times 3 raised to 3 plus 5 times 5 raised to 3 plus 5 times 7 raised to 3 plus 5 times 9 raised to 3. So now, we are going to apply the operations needed. So, 1 raised to 3 is 1 times 5 is equal to 5. 3 raised to 3 is 27 times 5 is 135. 5 raised to 3 is 125 times 5 is 625. And 7 raised to 3 is 343 times 5 is 1,715. And 9 raised to 3 is 729 times 5 is 3,645. And we are going to add all and with the total of 6,125 times 2 is 12,250.
Midpoint rule is a good approximation for estimating the area under a curve compared to the area using the left endpoints and right endpoints. Take note of this. If you increase the value of n using the left endpoints and the right endpoints, the value of the Riemann sums is going to be more accurate. As n approaches infinity, the Riemann sums approximation will become equal to the actual area. So that's all for
today's lesson. I'm hoping that you learned something through this instructional clip and that we were able to assist you in solving your calculus problems.
Ensure to click the like and subscribe button and turn on the notification bell to stay up to date on the educational content we share that will undoubtedly assist your calculus life.
Thank you for watching and see you in our other videos. Bye!